It's easy to think that our brains evolved to be able to handle language. But actually, it might make more sense to think about how our language evolved to fit our brains. Our brain wants two things from a language. It's easy to learn during transmission, and it's efficient to use during communication. These two pressures pull language in different directions. To see that, let's have a look at a simplified world. Our world has four objects. We can imagine a language where each one of these is labelled with the same word, poi. This is well adapted for our brains to learn. We just have to remember one word. But it would be terrible for communication. We wouldn't know which object we were referring to. A language that was well adapted for communication would have a unique word for every object. This is harder to learn, but better for use in communication. Our brains also want a language to be efficient to produce. So if we talk about black circles a lot, then we might want that word to be shorter, so we don't spend so much time saying it. We actually see this in real languages. Frequently used words tend to be short, while rare words tend to be longer. This is called Zipf's law, and it's an efficient design that may have evolved over many thousands of years. Another adaptation for the brain is iconicity. This is where the sound of a word gives a clue to its meaning. For example, if words for circles sounded round, or if words for squares sounded pointy. Again, across languages we tend to see iconicity being used more than we'd expect. For example, the word for round in many languages has an R, which sounds like rolling. Or the word for nose usually has an N in it, a sound that we make through our noses. These links between form and meaning might make learning and communication easier. Various studies have shown that languages may start being iconic, but then lose this property. For example, Simon Garrod and colleagues ran an experiment where participants had to play Pictionary together, drawing pictures to communicate simple ideas. Pictionary might feel like a strange game to use to look at language, but the point was to put participants in a situation similar to the first users of language. They had few shared conventions. Participants had a small set of meanings that they had to draw for each other. When they finished the list, they got given a new list with the same meanings but in a different order. They played through many rounds of this game so that the experimenters could see how the drawings changed each time they were produced. The drawings for computer started as a very detailed drawing, looking like the thing they were communicating. In other words, it was very iconic. However, over several rounds, these images lost their iconicity and became more symbolic. Maybe this is also how words evolved. However, other experiments have shown that iconicity can evolve later, and some others suggest that iconic meanings can actually be quite hard to learn, so there's some debate about this. The main point is that the brain wants language to be easy to learn and efficient to communicate with. These pull words in different directions. The easiest language to learn would be one word, but this would be terrible for communication. The most useful language would have a different word for every possible meaning, but this would make it very hard to learn. What would be the outcome of both of these pressures? Simon Kirby, Hannah Cornish and Kenny Smith ran an experiment to find out. A participant would come into the lab and be taught a little artificial language like this one. They had to try to remember it as best they could, then use the language to communicate in a communication task. The language they ended up using was taught to another participant, who also had to learn it and then use it in a communication task. This repeated over several generations with the language being learned and used each time. Because people make mistakes when learning the language, because they adapt it to be effective in communication, the language changed. The experimenters were not expecting a real language to be created. This is just a kind of simulation of what happens in a real language, with the important processes distilled down so that we can study them. Every time the language was learned, it came under a pressure to be easy to learn. Every time it was used for communication, it came under a pressure to be efficient to use. The language that evolved at the end was this one. You might notice that there's a pattern. Parts of the words are being reused in other words. So black things start with ne, red things start with re, square things end with pilu, and round things end with hopilu. This is called compositionality. Parts of words refer to parts of meaning, and they can be recombined into more complex meanings. This is the kind of structure we find in real languages today. Our languages are like Lego bricks. Each word is a small part that can be combined with other words to form more complex meanings. Hockett called this a design feature of language, and Herford says it's unique to human communication. But this special property is actually a compromise between a language that's easy to learn and one that's efficient for communication, especially when you start needing to communicate about more than 4 things. What does this mean for real languages? Many people assumed that language started as simple words for simple meanings, and then we started to combine them together to make more complex meanings. The bricks came first, and the bigger structures came later. But these experiments suggest that the first words were what Alison Ray calls holistic meanings. Early words would have had complex, possibly iconic meanings, and the smaller meanings evolved later as an adaptation to the constraints of our brains and the need to communicate. That is, the structures came first, and the evolution of language broke that down into different Lego bricks. The iterated learning experiment has been repeated many times with different types of meaning and modalities, including vocal and gestural, and also with computational agents rather than human beings. Oddly, many of them involve some sort of alien. Maybe it's because of what the experiments suggest about possible alien languages. As long as they need to be learned and used for communication, they should also exhibit compositionality.